cloud. Cool. And then focus, start focus mode. Okay. All right. Gotcha. Okay. Hi, Ronald. So I'm posting a link to a Nearpod. So go ahead and click on that link, Ronald, and sign up for the Nearpod so I can see your answers and everything. Okay. Welcome. So what we're going to be talking about is we're going to be talking about 2.01 atomic theory. And the reason why I wanted to go over this is because I'm seeing a plethora of students plagiarizing on the essay question in the quiz. And the essay question in the quiz is basically asking you to compare two different scientists. So it's not the same, it's a bank. So it has a bunch of different scientists to compare, but pretty much almost every, not all of them, but a lot of them have been plagiarized. Like you just kind of copy something because you don't really quite understand it. And I think it's because of the way the scientists are organized in the lesson. So what I wanted to do in this is go over the scientists and kind of clarify it for you. It will be something that you'll be asked again on your DBA also, so it is important to know. All right, so let's begin, okay? So the first thing to say here is that matter consists of atoms, okay? So in module 1, we were talking about matter, and we talked about all the ways that we can measure matter and, you know, what we, basically all the ways we measure it, how we can have physical changes to it or chemical changes to it. So everything consists of matter. And now what we're going to do is we're going to go a little bit deeper and we are going to talk about how matter is made up of atoms. So module 2 is all about the structure of an atom. Hopefully you know the structure of an atom. An atom is made up of a nucleus, and the nucleus has inside of it protons and neutrons. And then flying around outside the atom or outside the nucleus are the electrons. Okay, so there's 3 subatomic particles. You have your protons and your neutrons in the nucleus, and then your electrons flying around outside, around and about. Okay, so that is what an atom is made up of. And what we're going to talk about in this lesson is we're going to talk about the development, like how we discovered the atom, the current model of the atom. And this actually goes back to module 1, because one of the things in module 1 was talking about science, right? And reliable science, and how it has to be peer reviewed, and how it has to be globally accessed, and how you have to follow the scientific method. So this is talking about an idea and how we started with Dalton in the beginning, right? This guy right here, Dalton, and how he started with the atom, and then how the atom started looking like this. And then the next theory, it looked like this, and then it looked like this, and then it looked like this, and now it's just a big freaking mess. But this is the modern day model of the atom. And so we're going to briefly go through each of these and just kind of show the development of the atom. Okay, you guys cool? Good? We'll have questions in the midst of it too. So first we'll start with Dalton. This is the model, this is Dalton's model of the atom. It's a big sphere. And basically, actually, the atom first came from Democritus. But he just kind of like did it off the top of his head. There was no like research involved with it. Dalton was the first one to kind of start doing research on it. And what he discovered were these 5 postulates. So that's what they mean when they say postulates. Dalton's postulates are basically his 5 theories. And these 5 theories are that all matter is made up of atoms. So he's the one who basically said, all right, everything is made up of atoms, and that these atoms of a given element are identical in size, mass, and properties. So we can figure out one element from another based on its atoms. And then he said atoms cannot be subdivided, created, or destroyed in a chemical reaction. So they can't be, they are not anything less. This is it. There's nothing else in them. It's just a sphere, and that they can't be created or destroyed. You can't make them, you can't destroy them. And then he talked about how they combine in simple whole number ratios in chemical compounds, and how they react. And when they react, they rearrange, the atoms rearrange and form new compounds. But you can't like make something out of nothing. Usually you have to start with something and then they rearrange and they make something else. These are Dalton's postulates, and they're pretty spot on, quite honestly. Like he actually did a really good job. The only thing was is that as we and this is what they accepted. They accepted this. It was proven. But then Thomson came along. JJ Thomson. Go JJ. That's what I think of. I like his first name, JJ. What's up, JJ Thomson? JJ. This is him right here. He looks very happy. JJ, in 1897, he looked at Dalton's postulates and he was like, there's one that's wrong. And the one that was wrong is Dalton said that atoms were indivisible, that an atom was just a sphere. And what JJ found out is that atoms had even smaller particles called electrons. So JJ discovered electrons. That's what you need to know. So from Dalton to JJ, it was a sphere. The atom was a sphere. Can't divide it any further. It's just a sphere. And then JJ Thomson was like, wait a second, it's not a sphere. It's actually made of something with subatomic particles in it. And what he called it was the plum pudding model. And the plum pudding model is basically you have an atom and the atom is a positive charge and there's a bunch of electrons scattered throughout it. And it's kind of, the name is like, I'm really surprised that nobody's getting this because it's not that hard, but maybe they're just not seeing it. Plum pudding. Okay, this is actually what plum pudding looks like. It looks really good. It's like plum puddings and there's like plums and there's like bread pudding and they put like plums in there. And that's basically what he said the atom was like, is you've got this plum pudding, you got this positive charge and then the plums are the electrons. So this is what he said an atom was like. So Dalton said the atom was just a sphere, empty ball, okay? And JJ Thomson was like, no, it's a positive mass with these like little negative charges in them that are called electrons. So he discovered the electrons, okay? All right, so now, quiz time. Can you do it? Let's see.
And walk down this aisle with me. I would love it, yeah. Well, I say it's so early in the morning.
Go ahead and answer the questions. You can do it.
We're sitting here talking over cigarettes and drinking coffee.
Ah, I'm drinking, but I'm not smoking cigarettes.
I'd like to show you where I've known nothing but good old joy.
And it's okay if you get it wrong. You're not getting graded on this. You're just trying things out, and messing things up actually sometimes is just as good as getting it right.
I would love to have another drink of coffee now.
Jaden's not here today.
Help me smoke just
Wonder why.
one more cigarette
I miss him.
now.
He's always sleeping.
I don't want no cream and sugar, 'cause I got you now, dog. But just let me enjoy, help me to enjoy this good time that we'll have, man. It's so early in the morning, so early in the morning, and I got you, and you got me.
Okay. All right. So the first one, the first one says, which postulate of Dalton's theory did Thomson's model of the atom disprove? So if you remember, Dalton's theory is the sphere, and Thomson was like, no, it's not a sphere. It's not just like, there's more particles in it. There's something more to it. It's basically a positive mass with little negative electrons in it. Okay. So all matter is composed of atoms. That would not be it. Okay. Atoms of a given element are identical in size, mass, and other properties. That's not it. Atoms cannot be subdivided. This one's it. Atoms can't be created nor destroyed. Those are all true. So all of these ones, A, B, and D, are all true. Like those are still true to this day, which is pretty amazing. Dalton like came up with that, and like out of all of them, like they were all true except for the one about atoms not being able to be subdivided. So the correct answer for the first one is C. Atoms cannot be subdivided. Okay. Okay. So now for the next one. No, kidding. I did the wrong arrow thingy. My bad, my bad. Atoms cannot be subdivided. Okay, next one. There you go. All right, so how would you describe Thomson's plum pudding model of the atom? Okay, so nobody got this one right. Interesting. So a positive mass with electrons scattered through. Oh, you know why? I don't think I selected a positive. I don't think I selected the correct answer. It should be A. It's a positive mass with electrons scattered throughout it. So 3 of you got that right. If you picked A, you got it right. My bad. A solid sphere. Nope, that's Dalton. Okay. A dense positive nucleus with a lot of space for electrons. Just so you know, that's Rutherford. That's what we're going to learn next. A bread-like mass with plums scattered throughout it. Although that's the analogy, that is not what an atom is, although that would be quite tasty. So the correct answer for this one is A. I wonder if I didn't click the right answer when I made this. That could be the case because nobody got it right, but you did get it right. 3 of you did get it right. It is A. Okay. My bad, dogs. Okay. Any questions on that? Give me a thumbs up. Give me the thumbs up emoji if you get it. If you have any questions, you can put it in the chat or you can unmute. Give me some feedback, people. Good? Yes. Thank you. Okay, so now moving on. So we had Thomson. Then this dude called Rutherford came, and Rutherford looks very intense, doesn't he? He's like, so he was a pretty intense guy. Maybe it's because of all the radiation he was dealing with. Because this is when they were like researching with radiation, but they didn't realize that radiation causes cancer and all sorts of other things. So Rutherford was a student of Thomson. And he looked at Rutherford's plum pudding model and he was like, I'm not sure about this. I think I'm going to test it. I'm going to test it. And what he tested it with is he tested it with the gold foil experiment, which I'll show you on the next slide. And what he found is he discovered that it wasn't this positive thing with like negative electrons in the middle of it. He actually found that the positive stuff was in a nucleus. So you had this really dense little nucleus, and that's where the positive stuff is, which he called protons. So he discovered protons in the nucleus. And then he figured out that most of the atom is made up of empty space. And that's where the electrons were. So the electrons weren't scattered all throughout the positive mass. The positive mass was very condensed in the middle, and the electrons were all over the place. So he did this with the gold foil experiment, which they do ask you questions about this. And so the gold foil experiment looks really technical, but it's really not. It's actually just kind of basic here. So like I said, they were playing with radiation. So here's your radioactive source right here. They put it in a black box and they let the radiation go through a little slit and go through a lead screen slit. And they let it hit a gold foil, a piece of gold foil. And they had this screen around it that would catch the radiation as it moves through the gold foil. Now, if atoms were made up of the plum pudding model, if they were positive charges and they had negative charges all throughout them, what Rutherford expected to happen is he expected it to just go straight through to the other side. But what he found when he did it is he found that the radiation, a lot of it did go straight through, but that some of it bounced off onto other screens, which means that there was something very dense and solid in the middle of it. And through a bunch of other things, he figured out that it was positive charge, and he discovered it was a nucleus. So if you look at this picture down here, you'll see this is one atom right here, and that little dot in the middle, that's the nucleus. And you'll see that when the radiation hit the nucleus, it really bounced off. But then if it didn't hit the nucleus, it just went straight through because most of the atom is empty space. So it's pretty crazy he came up with this, but from this experiment, he came up with the fact that, okay, an atom has a very dense nucleus made of protons in it, and the electrons are flying around and out of space, and that's mostly what the atom is made up of. Most of the atom is made up of empty space, but he found these little dense little nucleuses around that, okay? Okay, so next question, an open-ended question. Compare Thomson's model to Rutherford's model of the atom and go. Doing that, guys. I'm taking you there. I'm taking you to the limits of atomic theory. You can do it, people. The only bummer about this is you can't go back in the PowerPoint and look. I'm sorry. You know, I wonder if it would help if you saw the PowerPoint. Does anybody remember eHarmony commercials? This is an eHarmony commercial. I don't know if that's known.
This will be an everlasting love. This will be the one I've waited for. This will be the first time anyone has loved me. I'm so glad.
Put the link to the PowerPoint on there, so you can look at the PowerPoint as we go along too. It's a lot to open, you know, you don't have to, but I'm just saying if you want to look at the PowerPoint so you can look back, you can. I'll just give you like a minute or two more. It's a great song. right, we'll stop there. Okay, so compare Thomson's model to Rutherford's model of the atom. So in some of your answers, you gave the similarities between them, which is fine. But typically when we say compare, although I get why you're doing that, because we have this question we ask now, it's a compare and contrast. And that's a very interesting question because compare can mean giving both the similarities or the dissimilarities. You're right in saying that what's similar about them is that they both talked about electrons. Okay, so they definitely did both talk about electrons. But the big thing here that you need to know is like the difference. We're comparing them and saying maybe I should have reworded it differently and saying like, what's the difference between Thomson's model and Rutherford's model, or what did Rutherford prove differently from Thomson's model? Because that's pretty much what the question, the essay question asks. It asks you, how did this scientist disprove this scientist's model? And so the answer would be that in Thomson's model, the electrons were scattered throughout the atom. And in Rutherford's model, okay, the electrons were in the empty space flying around a nucleus, a dense nucleus with protons in the middle of it. So in one, you have Thomson's, which is the one where you have the positive charge with the negative charges throughout it. And then in Rutherford's, we're basically starting with like a nucleus with the positive charge and the electrons are like out here, but he doesn't know where, he just knows that they're mostly in empty space. So that was the answer that we were looking for on that one. Does anyone have any questions on that? Give me a thumbs up if you are good. You can give me a thumbs down if you're not. Okay. All right. So now let's develop it even further. And so now what we're going to do is we're going to talk about Niels Bohr. Niels Bohr looks like a mess. It looks like he didn't sleep very much, quite honestly, to me. I mean, he looks like like he's had some rough nights. And maybe it's because he was dealing so much with, heating up elements and making like these like light things out of them and stuff. But Niels Bohr, he worked with Rutherford. Okay, so these are like all kind of people in the same area. And what he proposed is he was like, I'm not really sure that the electrons are just flying around. I think that the electrons revolve around a central positive nucleus, like the planets in the solar system. And so what he came up with is he came up with this idea that you have your nucleus right here. And he said that the electrons were arranged in these shells or orbits, okay? These shells had a certain amount of energy, and this energy in the shell is what held the electrons there. So these two electrons here hung out in this shell because there was a certain amount of energy in that shell that was holding it in that place. And then this shell was holding this electron in its place. And then you keep going and you have another shell or orbit that would hold more electrons. So there's a certain amount of energy that would hold the electrons in place. This is going to be really important for you to understand because this is going to be the basis of what you're going to be learning about in 2.02 and 2.03. You're going to be doing a lab where you're going to be exploring what Bohr did, because what Bohr did is Bohr like heated up elements, and he found that electrons, how he figured this out is he found that electrons would get excited and they would move up to other shells, and when they came back down, they'd release energy in the form of light. And so all elements have a color. When you burn an element, it has a certain color to it. And it's because of the electrons getting excited, moving up to other shells. And then when they come back down, they release that energy in the form of light. So this is how he figured it out. I don't know how you figured that out from that, but he did. It's pretty amazing. It's probably why he looks so rough, is because he was figuring that out and I couldn't figure that out. So that's what he said. So now we've got Dalton, who said it was a sphere, and that's it. Thomson, who said, no, it's not a sphere. It is a sphere, but that sphere has negative electrons scattered throughout it. Rutherford, who said, okay, well, the negative electrons are in this empty space, but there is a positive charge, and it's in this really dense nucleus. And then Bohr, who's like, you're right, there is a nucleus that has a positive charge to it, but the electrons aren't flying around everywhere. They're in these shells. They're in these orbits around the nucleus. Okay. All right. So in Bohr's model, this is what that's what I was just saying, is that the electrons can only revolve around certain orbits and at certain energy levels. And what we said is that those energy levels were quantized, which means there's a certain amount of energy to them. And so it's kind of like steps. Like there's no energy in between the steps. There's this energy moving from this step to that step. And that's kind of how the shells were. Okay. Okay. Quiz time. 2 questions. You can do it. Baby, I need your loving.
Another day, another night, I long to hold you tight, 'cause I'm so lonely. Baby, I need your loving, got to have all your loving. Baby, I need your loving, got to have all your loving. Some say it's a sign of for a man to beg, then weak I'd rather be, if it means having you to keep, 'cause lately I've been losing sleep. Baby, I need your loving,
Got to have all your loving.
baby, I need your loving, got to have all your loving.
Anybody doing anything fun this weekend? I'm not. Put it in the chat. Hey, Danielle is here.
When you see me smiling, you know things have got
Ooh. Are you getting a new phone, Kayla?
has all been hers. Darling, I can't go on without
Hi, Danielle. Here's the link to the Nearpod.
Okay, ma'am. I'm on my phone, but I'll type it on my computer.
Oh, it's okay. If you're on your phone, you can just watch. Or you can do it on your computer, whatever you want to do. We're about, got 7 more slides, so it's up to you, okay?
Okay, ma'am. Thank you.
You're welcome. Glad you're on.
Dedicate this song to little Junior Parker.
Okay, let's go ahead and let's get going.
Cousin of mine.
Okay, so the first one is, which statement is correct regarding Bohr's model of the atom? Okay, so the first one says he described an atom as a positive mass with electrons distributed throughout it. That we all know is not Bohr, that's Thomson now. He's the plum pudding guy. The electrons are found in the dense nucleus of the atom. Nobody has said that, because electrons are not found in the nucleus of the atom. They are found around the nucleus. The electrons do not have a set location around the nucleus. Nope, we have not said that yet. That's kind of more Rutherford's thing. And then the electrons are arranged in rings around the nucleus. That is correct, like the planets. And so it is D, okay? Oh, kidding. Gosh darn, I did it again. I went to the wrong thing. Sorry. It's because I have 2 screens going. I have the teacher screen going and I have my screen. So D. Okay, next question. So the next question was, what holds the electrons in the orbits around the nucleus? So what holds the electrons in the orbits around the nucleus is energy. And that's what you're going to be talking about in 2.02 and 2.03. You're going to be talking about the energy that's holding the electrons and how we can mess with it and make super cool things happen as a result of it, like fireworks. Are you excited? Can I see some excitement? Maybe just a thumbs up. Or if you have a question, please feel free to let me know. Yes, yes, my mind is blown. Oh, Kayla's not excited. That's okay. All right, now let's move on. I gotta tell you, there's not much on Chadwick. All you need to know about Chadwick is Chadwick discovered the neutron. The neutron is found in the nucleus. How he did it, I tried explaining it in the video, but I'm going to be quite honest with you. It's a little crazy. It has to do with radiation and the foil and the you know, the whole screen thing again. But like, you don't really need to know that one. The main one you need to know is the gold foil experiment. Chadwick, you just need to know that he discovered the neutron. The interesting thing was is that he like studied with Rutherford, and then he like 20 years later, he discovered the neutron. So it was later. So you can see he's a little more well rested than the other guys. He looks good. And then from there, we go to the last one. And this is pretty much where we're at today. It's called the quantum model of the atom. And this is with Heisenberg and Schrodinger. And there's actually two little dots on top of the O, Schrodinger. You can see they look like pretty happy guys. And these guys, what they came up with, this is a really weird kind of thing. But basically what they found is they found that electrons do not move in exact orbitals. So if you remember Bohr's model, I love Bohr's model. It makes so much sense to me, right? You have an electron in an orbital and it's just rotating around like a planet does around the sun. And then we can say that the nucleus is the sun and like, you know, the electrons are the planets. But that they found, Heisenberg and Schrodinger found that that is not the case. You can't find the electron. And what they decided was, or what they realized through study, is they realized that electrons exist in these things called electron clouds, which you'll be learning about a little bit more later. And electron clouds means that there's a space where there's a probability of where you can find it, but we're not sure exactly where in there the electron is. So it's a space of probability. Somewhere in this vicinity of a space, you can find an electron, but we are not really quite sure where in that space. And this is called the quantum mechanical model. And that's what you're looking at here. That's what this is. If you notice, it just looks like it looks like dirt. And you can see there's the nucleus right there. And then if you notice where the dots are denser, that's where there's a greater probability of finding an electron. So that's the theory. That's the quantum model theory. And we'll talk more about that later. You'll learn more about that. Okay, so that's it. That's the whole thing. Oh, sorry, I forgot this slide. So this is just kind of showing it a little bit more clearly. Okay, so like the way to think of this is there's still shells. So in an atom, the electrons are still found in these energy levels. Okay, so there still are the shells, the 1, the 2. So we still have this idea of this. It's just that the electrons aren't in this line around it. There's like a space in this area where there's a probability of where you can find the electrons at. And one thing just to note here is if you notice there's no electrons in this space right here, and that's because of this idea that the electrons are quantized. Quantized meaning that there is a certain amount of energy that's holding it in place, okay? So that is how it works, okay? So they can, and so the electrons can be found anywhere within the shell. That's kind of a more, it's a nicer way of seeing it, okay? Okay, so now, open-ended question. What is an electron cloud?
It's going on, but we'd like to kind of carry on.
keep trying to tell me all you want to do is use me. But my answer ain't all that use me stuff. I want to spread the news that if it feels it's good getting used, oh, you just keep on using me until you use me up. Until you use me up. My brother.
All right, good job.
Sit me right down and he talk.
Okay, so everyone did well on that one. So pretty much there where the electrons are surrounding the nucleus. The only thing, just to kind of clarify on there, it's the space of probability, the space where you could possibly find, ooh, hey, let's spell it right, possibly find the electrons around the nucleus, okay? So it's not a definite space, it's a cloud of probability, is what they say, okay? So it's like the space where you could possibly find electrons around the nucleus, and it's not definite, but you did a good job on that one. Very good. Okay, good job. Oh, do I submit it? I'll submit mine too. All right. So that's it. This is the history. So just to review again, to clarify, make sure we see it. Okay, we start with Dalton, double D Dalton, okay, and he's got the spear. An atom is made up of a spear. It's indivisible. It's can't be created or destroyed. All elements are made of it, or all matter is made of it. Then we got J.J. Thomson discovered the electron with the plum pudding model. You got Rutherford. Rutherford discovered that the electrons are not scattered throughout. They are actually outside, and that the atom has a very dense core of the nucleus, and that the protons are in the nucleus, and that the electrons are randomly around it. Bohr was like, look, bro, those electrons aren't randomly around it. They're in these orbits. Okay, but there is a nucleus. Chadwick was like, hey, check out, there's a neutron in there too with the nucleus along with the protons. And Schrodinger and Heisenberg, and they say and others, created the quantum atomic model, which is, yes, there's a nucleus with protons and neutrons in it. And yes, we have electrons in shells, but we don't know exactly where they are in those shells. They're in these clouds of probability of where we could possibly find them. So that is the history of the atomic theory. And now what you're going to do is you're going to do matching. Go for it. You can try it again.
Behind a rainy day, I'm in a snake back situation. Here's a pencil pad.
You guys aren't doing well.
I'm gonna spread some information.
Yes, you're getting better. Good. Keep trying until you get it. Come on, you can do it.
I get a dark blue ring. I get a snapback raincoat worth of blue yonder. I get a purple stain.
Almost.
Beside the whistle cat.
Yes, good. Okay, so going through them. Okay, so we'll start with all matter is composed of atoms. That's Dalton. Okay. Thomson's plum pudding model. An atom consists of positive mass with electrons scattered throughout. Let's do Rutherford's model. Rutherford's model is atom contains a dense positive nucleus with electrons flying around in open space. Then we go to Bohr. Bohr said that the electrons orbit. Okay, and then we did Chadwick. Chadwick discovered the neutrons, and then the quantum is the electrons can't be located. They are found in electron clouds and energy levels around the nucleus. All right, that is it. So we are done for today. So you can check out the picture is funny. Oh, you can't see it. It doesn't open. This is so boring. Get it? Anyway, post your questions, comments, or concerns here. You know, if you found this helpful, if you didn't find this helpful, if there's something you still don't understand, if you need me to stay after to help you with something else, I'd be happy to talk with you. That is all we have. Please post a comment, and then you are free to go on your merry way. Thank you for coming, as always, ladies and gentlemen. I appreciate you being here, and have a great day. Good. Good. Yes, the theory of atoms did change a lot throughout the years. Thank you for coming, guys.
Thank you, ma'am. Have a good day.
Thank you, Danielle. Take care. Glad you got to make it. We see you, Kayla. Hi. Good. And you're free to leave once you post. Bye, Kayla. Have a good birthday. Ethan, do you have any questions or anything? You good?